Hello, welcome to this video of vectors. In this video we'll be looking at distances from planes. The first distance we want to look at is the perpendicular distance of a point from a plane. Now see the coordinates of our point are x0, y0, z0, and our plane is given by this equation ax plus by plus cz plus d is equal to 0. The perpendicular distance of that point from that plane would be given by the absolute value of ax0 plus by0 plus cz0 plus d divided by the square root of a squared plus b squared plus c squared. So for this particular example, the perpendicular distance of the point T from the plane given would be our a, you can see, is 1 and our x0 is 3, our b is -4 and our y0 is -2, our c is 5 and our z0 is 1, and our d is -7. Since when you take the 7 to the left, it becomes a negative. We're dividing this by the square root of 1 squared plus -4 squared plus 5 squared. When you solve this, this should give you 9 out of root 42 units, and that's how you calculate the perpendicular distance of a point from a plane. Okay, how about the perpendicular distance between two parallel planes? Say we have two parallel planes like I'm illustrating right there. The perpendicular distance we're interested in is that distance right there. So what do? We simply locate a point on one of the planes and then find its perpendicular distance from the other plane using the formula that we've seen on the previous slide. So if we decide to pick out this equation, we could decide to set our y and z to 2 and see what the x value would be when y and z are 2. So x would be, once you solve that equation using the equation of a plane, you get your x as 13, and hence the point 13, 2, 2 lies on this plane right here. And so we find the perpendicular distance of the point 13, 2, 2 from the plane 3x minus 6y minus 6z is equal to -13. So that distance would be 3 times 13 minus 6 times 2 minus 6 times 2 plus 13 out of the square root of 3 squared plus -6 squared plus -6 squared. Don't forget the absolute value signs. And so this gives us 28 out of 9 units, and that is indeed the perpendicular distance between the two planes. You could also decide to pick a point on the second plane and find its perpendicular distance from the first plane. Both ways should still give you the same answer. Okay. Now how about between skew lines? Skew lines are lines which are not parallel, but they never meet. The reason they never meet is because they lie in parallel planes, and so despite them not being parallel, they actually never meet. And so the distance between skew lines, the perpendicular distance between skew lines, is in fact the perpendicular distance between these two parallel planes. And so to find the perpendicular distance between skew lines, we just need to find the perpendicular distance between the two parallel planes. So what do? We get the cross product of the directions of the two lines, and that will give us the normal vector to both planes. And once we have the normal vector to both planes, we can find the equation of one of the planes and find the perpendicular distance of a point from the other plane from that plane. That's what we're going to do in the example that follows. Okay, so this example asks us first of all to check if the following pair of lines intersect. So let's do that first. So we have the line x is equal to 1 plus t. These equations are in parametric form. Y is equal to -2 minus t, and z is equal to 3 plus 2t. And then we have the line x is equal to 4 minus s, y is equal to 5 plus 2s, and z is equal to 6 plus s. So we can pick the first pair of equations and solve them simultaneously. When you actually solve those equations simultaneously, you get your s as -10 and your t as 13. You can confirm and see that these values of s and t indeed satisfy the first pair of equations. However, for the third equation, using our values of s and t obtained, we'll get our z as 29, and we'll get our z on this side as -4. And so that means that these two lines do not intersect, since there are no consistent values of s and t that satisfy these 6 equations. So these two lines do not intersect. And so that means that they are skew lines, so they lie in parallel planes. So what do? We have to find the cross product of the directions of the two lines. So we can first write the lines in vector form. You realize that when we write them in vector form, we'll have this as 1, negative 2, 3 plus t times 1, negative 1, 2 for the first line. For the second line, we'll have r as 4, 5, 6 plus s times negative 1, 2, 1. So you can see from these two equations that the directions of the lines are 1, negative 1, 2 and negative 1, 2, 1. So to get the normal to the planes, we would have to get the cross product of those two direction vectors. So this would be the determinant of this 3 by 3 matrix, as we saw how to get the cross product in previous videos. And so when you get this cross product, it actually is negative 5, negative 3, 1. That's the normal vector. Of course, this is the same as negative 1 times 5, 3, negative 1. So you could decide to use 5, 3, negative 1 as your normal vector, since it's just in the opposite direction. And so we can use this normal vector to get the equation of one of the planes. We can decide to get the equation of the plane that contains the point 4, 5, 6. So the equation of the plane that contains this line. And we know that equation is given by r dot n is equal to 4, 5, 6 dot 5, 3, negative 1. This is the same as 20 plus 15 minus 6, which is 29. So we have that 5x plus 3y minus z is equal to 29. Of course, if we take the 29 to the left, we'll have a 0 on the right. So this is the equation of the plane. The point that lies on the other plane is 1, negative 2, 3. So the distance between those skew lines would in fact be the distance, the point 1, negative 2, 3 from the plane that we've just got. So it's going to be 5 times 1 plus 3 times negative 2 plus negative 1 times 3, but then minus 29, and we're dividing this by the square root of 5 squared plus 3 squared plus negative 1 squared. And we're getting the absolute value of that. And that distance is in fact 33 out of root 35. And that is the perpendicular distance between the skew lines.